Another Dibs research video. What's up, research nerds? We are back for yet another video. We're going to get into a lot of stuff today. We got a big video ahead of us. But really the first thing that I wanted to do today is talk about the assignments you've been doing. One, hopefully you guys have found 5 people to reach out to for potential mentors. Again, do not reach out to anyone yet. We're going to do that together, but keep thinking about this. Always keep this in the back of your mind as you come across new people, other options, and you start to make connections, or not make connections, but find potential connections, right? Make sure you're writing them down and keep it on track. 5 is really a minimum, okay? I'm hoping you guys found 5 potential people, and hopefully, if you haven't already, part of your work in class, if you finish whatever the weekly work is to maybe dive into those potential people and learn more about them. The more you know about the work they've done and the research they've done, and the higher level that you can speak about their research to them, if you eventually do get a meeting, the better off you're going to be in terms of hopefully finding a mentor. So the more work you can do up front, the more it's going to pay off as we go. So I just want you guys to keep that in mind, keep that in the back of your head as you're going. Next, I want to talk about the assignment that you did regarding your typing speeds and the ROL, taking a look at your data. You guys did a great job, but there's just a few things that I want to address, and I just kind of want to go over what the expectations were for the benchmark you submitted in terms of formatting and stuff like that. So let's jump into that. So this is your scatter plot for all of you guys. So this is the big one that you guys shared with me that has data from both classes in it. And this is what I love to see, man. I love to see that R-squared value, 0.004. That is an extremely low R-squared value. So that means there is no statistical relationship between the speed that you guys were typing and the length of your paper, which means the length of your paper was determined by the ideas you were getting across, and you guys did a great job editing it, right? If you guys just whip something up, I'm sure we'd see more of a relationship there. So seeing that R-squared of 0.004 is awesome. I think one of the classes is an R-squared of 0, which is incredible. Statistically, that's pretty remarkable. So that was awesome to see there. Next, I wanted to bring up, I'm actually going to bring up Mackenzie's right now just because I know she's going to hate it if I bring hers up. But she actually did a really great job, and I just want to talk about maybe a few things she could have did here that would have made this better from a formatting standpoint. So first off, she's got results bold at the top, then she's got her subtitle. One thing to remember, guys, subtitles should always be left justified like this, and I think they should be shorter as well. They should be something that really catch your eye as a reader to these papers. Our number one thing with formatting is we want to be kind to our reader. So before I do that, though, another big thing from Mackenzie here is spacing. Our spacing should be, why is this not scrolling down? That was annoying. Didn't plan for this, guys. Excuse me. Is there like a select all? Oh yeah, there we go. I'm going to double space her paper. Everything that you guys do in APA formatting should be double spaced, and I'm also going to make sure under the spacing thing both of these are good, and I'm going to remove this line so we're in control of all of the formatting. So instead of saying effective words typed per minute, what we are going to say is I'm just going to be relationship between typing speed and ROL length, right? So we'll just throw that in a little bit shorter and tighter. Now, she's got some great stuff in here in this first paragraph. Figure 1 depicts a scatter plot that represents the correlation between a number of words typed per minute and the number of words for each student's paper in period 2. The graph shows that there was an R-squared value of 0.22, meaning that's where we need to delete this. Okay, so when we're writing, we don't need to explain our statistics. This is an important thing. So we are just going to go boop, right? We're gonna get rid of that. We don't need to explain what it means. We're gonna say there's an r-squared value, and then we're gonna explain what it means in the context of this, which is, this depicts a very insignificant correlation between the words typed per minute and the number of words written in that period. All right, awesome. Then she has the graph to kind of go along with this. One thing that I'm gonna do here with the graph though, guys, is I don't like the title that Google puts in there. And one thing you can do really easily is to crop this. If you go up to the crop image thing and then just like get rid of the title, okay, like this, hit enter, right? Now I've kind of like shaved that title off and it just kind of sits there, and I'm going to write the title down here, right? So I'm gonna say figure 1, which I don't believe has that there, and then I am just going to write the title as period 2 ROL length versus typing speed, right? So I'm just gonna put it in like that, and I think this looks a little cleaner, and I don't believe this is bold either. You guys can double check the formatting guidelines. So there's my title, there's the graph, and everything kind of fits in there. Now, what Mackenzie is missing here at the bottom of the graph is a note. So what you guys want to do is put a note in, and that's going to be in italics like this. You're going to say note. This graph shows no relationship between typing ... And then what we do in our note is we want to highlight what's important to the reader about this graph. When I look at this graph, what should I be seeing? And one of those big things that we should be seeing is an r-squared value, right? So that's what's giving us our evidence that there is no relationship. So we want to tell them what we are seeing in this graph. We don't want to leave that up to them. Another thing that I like to do with the notes is indent them to match the graph itself. So what I'll do is I'll kind of grab these guys up by the ruler, my left indent, and I'll pull it in to match that graph, and same with the right side here. I'm gonna grab that and I'm gonna pull that in to match the graph. So this way, no matter what I type, it's gonna sit under that graph really nicely. So we'll make sure we have that. Now we've got to fix some of the spacing here. Awesome, and we could go on, but otherwise Mackenzie did an amazing job. She's got all three graphs, graph now from period 1, and then the graph for everybody all together, which is awesome. So Mackenzie did a great job, great job. A lot of you guys all had good stuff in here, and I just wanted to highlight those little nitpicky things that are gonna come into play later. You're gonna be doing another one of these after we survey the freshmen, which is what we gotta talk about. So, on Monday, you guys should have gotten into groups and thought about some hypotheses about the freshmen. What do you think is the deal with these guys? Okay? So, as you saw last year, you guys answered a survey with seemingly random shenanigans of questions. And you guys are going to be doing that to the freshmen now. And there are no rules, outside of obviously the questions being school appropriate, right? There are really no rules about what we can ask in this survey. So we need to come up with some stuff that we can ask, okay? And I want you guys to start thinking first here about what are 2 things that we can look for a relationship between. Right? Let's look for a relationship between maybe GPA and number of sports played. Things like that. Those are 2 variables. Number of sports can vary in between like 0 to 3, 4, 5, depending on sports outside of school, right? And then GPA can vary anywhere from 0 to 100, right? However, I also want you, as you start thinking about this, to keep in mind the demographic that we're surveying. We're surveying freshman research kits. So you've got to think like number of honors classes taken. that's going to be pretty much the same across the board for all of our students, right? Most kids are in honors classes. There might be just a few outliers there. So think about the population that you're going to be surveying. Come up with some hypotheses that could be interesting for that population. And let's see if we can find if there's a relationship between two things, or if there isn't a relationship between two things. So I want you to think about what those are going to be. We're going to ask questions, you're going to gather the data in a Google form like we just did, and you're going to make a scatter plot like we just did, okay? But what I now want to talk about is the next thing, okay? We have found how to find a relationship between two variables. But we also need to have our second piece to the toolbox, which is finding a difference between two groups, okay? So as we get into this, you're gonna find now two relationships between two variables in your survey, and you're also gonna look for a difference between two groups twice. You're gonna find, is there a difference between GPA and males or females, right? So let's look at an example we already have data for that you guys gathered, right? So if we come back over here, let's take a look at this. This is all of the words per minute data for period 1 and period 2. So, is this a variable, words per minute? Of course it is, right? We have varying amounts of typing speeds in both classes. They varied quite a bit, right? Was one class faster typer than the other class? So what would we do to analyze this? If you're sitting there thinking, well, look at the average typing speed of both classes, you would be right. That's how we would compare this. So if we come down here and scroll down, I've done that. I've found the averages for both classes. So as you guys can see, period 2 here has an average typing speed of 59 words per minute, while period 1 has an average typing speed of 52 words per minute. So is period 2, on average, better typers than period 1? Well, I think the answer to that will be kind of interesting. So to figure this out, we have to know a little bit more about data. So let's go and take a look at what's called a histogram. So hopefully you guys have seen a histogram before. You know what a histogram is. So here we go. This is a histogram of everyone's typing data. Okay? So in this histogram, as you can see, most people had a typing speed between 48 and 58 words per minute, right? And then it tailed off in two directions. Some people down here were slower, and some people up there were higher. If I was to draw like a curve of best fit for this, maybe it would look something like this. Right? Yeah, not the best curve. Let's try that again. Here we go. There we go, that's better. That fits the data a little bit better. And what we notice up here is the tip of this curve, this is the average, right? And we've talked about this, you know, you've probably talked about this with your teachers in terms of like a bell curve, right? Where there are a lot of people here at the lower end of the average, or not a lot of people here at the low end, not a lot of people at the high end, and everybody clustered towards that mean, right? And that's what we see here with your guys typing. This follows a standard bell curve. This is awesome to see. So when we have a standard bell curve, in statistics, we call this a two-tailed distribution. So why do we call it two tails? Well, I think the best way to explain that is to think about a dinosaur tail, right? So if I take this tail and bring it over, here we go. If I bring this dinosaur tail over to our graph, you can see that the data tails off, kind of matching that dinosaur tail. And that's what we mean when we say a two-tailed distribution. There's a dinosaur tail going to the right and a dinosaur tail going to the left. Not all data is two-tailed, right? But most of it is. And your goal as a researcher is to develop questions that are two-tailed distributions. This means there's not much bias in your question design, right? A good question follows a nice bell curve. Now, is there some bias in our questioning here? Maybe a little bit. We can see more people on the left side than there are to the right side. So there's a little bias there in our questioning, and this is probably, due to some external factors. Maybe in this case with typing speed, maybe there's some bias here, not a lot of people towards the higher end, because the people at the higher end maybe went to an elementary school where they did typing, like those typing classes where you learn how to touch type, right? Or they're involved in hobbies where they're typing a lot, and some of the other class is not involved. So there's a little bit of bias there where most of the classes did not have that experience, and they're shifted over here to the left side, right, towards that lower end of the mean, and then we have some more outliers to the right side. So this is just kind of, in my opinion, a pretty interesting kind of little tidbit to talk about with data, right? There's always going to be bias in our data, but we know a good question when we do see the bell curve, and this was a good question. We did get a nice bell curve. Okay, so we're back here, we move the dinosaur tail, and now let's say we were to compare our data to, let's say like period 2. So I'm going to draw period 2 as like an orange line. Now they had a slightly higher average typing speed, which means their distribution is probably pretty similar, but it's going to peak a little bit later here on this graph, right? So their average is going to be higher than period 1, right? However, is there a lot of overlap here? Yeah, this whole area is all overlap from both sections. So is it a significant difference? I don't know. Kind of hard to tell, right? So when we're looking here, the big thing we're looking for is a significant difference between two groups, right? So we could be looking at, two different averages that are really close, like our typing speeds, and they overlap a lot. Or we could be looking at, two peaks like this that only overlap a little bit. This would be a significant difference. And this would be no difference. So what we need to do is find a way to quantify this and display this. Okay? So let's talk about how we're going to quantify this and how we're going to set this up. What I want you guys to do right now is open up your Statistics with DeBello document, wherever you guys have that, and then again make a list of instructions to your future self to be able to do this. You're going to need this for your next assignment when you go to analyze the data from your survey, and you're going to need it next year when you go. This especially is something you're going to do probably a ton of, and this is probably the thing that I reteach the most, and I would love to not do that. I would love to just do it now. And then you guys learned it and then could do it later because you left good notes for yourself, right? That sounds nice. It would be nice. So let's do it. The first thing you want to do is get your data from its original format like this, right? Where we have everybody's data all at once, both classes all together, right? We got words per minute, right? And then what we want to do is get it all together like this. So I've kind of titled it up here. So I made a new sheet. I've titled this one words per minute at the top. And then I have period 1 and period 2. So what I did was I copied all of period 1's data, right? Or actually this is all period 2's data. and I've copied that into the period 2 thing, and then I went back and grabbed all of period 1 stuff, right? I've grabbed all of that, and I've copied that into its own column there. So now I have all of the words per minute for period 1 and 2 separated, okay? Then what we're gonna do off to the side is we're gonna make a chart. And the way we make this chart matters, okay? There are 2 ways. We could make it like this, where we go, okay, we're gonna have period 1, period 2, and then we're gonna have average, okay? And then I could put those values in here. So I have 52 and 59. So we got 52 and 59. So I've got my averages here. I'm gonna highlight this and make a graph. Now another way I could have done it is gone like this. Average words per minute, right? And then done period 1, period 2, right? So I could have done this and done 52, 59. This is bad. Well, it's not bad. It's just not gonna work with Google Sheets with what we wanna do. Okay, so do not set it up like this. Make sure you set it up like this, and we'll see why in a little bit. So we've got our setup here. We've got average. I'm just going to add average words per minute. So we've got our lovely little setup here, and we're going to use a bar graph to show a difference between 2 groups. Okay? Now, one thing that I want you to make note of here. You do not highlight your data and make a bar graph. If you just highlight data and make a bar graph, you will get something very hideous. A bar graph is just an artistic representation of your analysis. So we had to do the analysis first. We came down here and did our analysis by finding the averages first. Let me go over how to do that with you guys right now. The easy way to do that is to come over here and type equals average, in all caps, open a parentheses. When you do that, go over there, highlight all of the numbers you want to take the average of. If you highlight blank spaces, they just don't count. Google's very smart, and we get 52. If I want to do that for this column, I would do the same thing, except I can actually click on that little circle on the corner there, drag it over, and it'll do it for me. But again, just for emphasis, what I can do is go equals average. Make sure you type that equals sign first. So that's going to be important. That's telling Google, when you type an equals sign first, it tells Google, okay, I want you to do math in this box and not something else. So we're going to type equals average. We're going to scroll up, and we are going to highlight all of the data points that we want the average of, and hit enter. And we get 59. So that's how we can find averages of large amounts of data very easily. That's our analysis piece. Now we're gonna make a graphical representation of that. So we can make a nice little chart like this and highlight this chart. This is how you need to have your chart laid out. Make sure your groups, period 1 and period 2, in this case, go on the top, and the variable average goes here on the left. Needs to follow that convention. Then we're gonna go to the insert chart button. We're gonna insert a graph. Oh, what in the world is this? So we get this weird thing. I hate the sideways bars. So I'm gonna click a column chart, and we're gonna put in a column chart here. Let me make this full screen here so we can see it a little better. There we go. And then let me come up here and get my face out of here. Okay. All right, so now we have our column graph, and what we want to do is go in and look at it. Firstly, do you notice how we have 2 different colored bars? This means you did it right. If you have 2 blue bars by default, you set it up wrong. You should have 2 different colored bars. Make sure if I switch them, it's going to look like this, which looks really good, doesn't it? Right? If I have 2 different colored bars, like a period 1, period 2, labeled on the bottom, great. That looks great, but that's not what we want. We want the 2 different colored bars, okay? And then you could just make sure, here it says use column E as labels. right? We got to make sure that's checked. So just make sure your check boxes here match mine, okay? And we have a column chart. Then we go to customize. Now we actually have a lot of work to do when we customize because the defaults don't do a good job here. So my chart title, period 1 and period 2 words per minute, we got to make sure we add that in. It doesn't get added into the title by default, okay? We're going to go to the horizontal axis. Notice that's titled average words per minute, but that's not what it is. So we've got to type this in. We got to put something. So I'm going to type period 1. This is weird. I don't know why. Wow, that's kind of terrible. So I don't know why it's saying average words per minute on the axis there separately, so that's strange. So we'll just leave that blank for now. But our vertical axis we do want to label. So we want to make sure we label our vertical axis average words per minute, because that's what we actually have. So we'll label our vertical axis average words per minute, just like this, okay? Let me move it out from where my head is. There we go. So now we have our graph, and we're going to need to delete this title here. I don't know why. I don't know where that info is. I don't know why it's being weird. Maybe if I just, can we just get rid of it? That made it smaller. Text color. Is this what it is? I'm sorry, I feel like unprepared right now. Let's just make it white text. Yeah, now it's gone. Okay, great. So we get rid of that. And now we have average words per minute on the y-axis. Now our graph is starting to look pretty good. One of the things you can do now too is go back into your chart axis and titles. Now we'll go back to our horizontal axis title and do like period 1, and then a lot of spaces, and then period 2, right? And what we can do is kind of add spaces in here until they kind of separate and fit nicely under each one. So there we go. Now we have it labeled period 1 and period 2 like we want. We also have this lovely little box up here, which is using colors to show the difference. However, when you go to submit your paper to some competitions, it's going to submit in black and white. So making sure that we have distinctions even without color is actually a really important thing. So first, play with your axes and axes titles to make sure everything is fine and dandy, okay? But do we see a significant difference between these two? The answer is, looking at it like this, not really. However, I want to show how statistics can kind of be changed to fit a narrative. And this is something we see in the news all the time, right? If I showed 0 to 100 as our lines, we would see two bars very, very, very close, right? But what if I set my minimum and maximum on the y-axis from 50 to 60? Ooh, look at that. Oh, period 2 is dominating, right? This is something we see all the time to get data to fit a narrative. And this is where we as scientists need additional information to make really important distinctions. So let's go like, 0 to 80. There we go. What we need to see is the distribution of that data, right? So if we come back to like what we were talking about here, where we have these distributions of our data, right, that spread with multiple tails that we get, how much they overlap matters. So how do we show that in a bar graph? Well, you've probably seen this in some of your research papers, okay? Well, now, guys, it's time to get serious again. Click on series. And what we can do is scroll down and click error bars. These error bars show us how much these values vary from the mean. Now, when I just click that button, it just automatically makes an error bar that's 10% of the total amount. That's not what we want to show. So we need to do an additional statistical test here in order to see the spread of our data. Okay, so let's close out of our chart for a second and let's move our chart out of the way. Move it down here. There we go. That's good. But what we want to do is we want to get some additional info. Let me move myself back over here. Oh, there we go. So what we want to do is find how much our data on average deviates from the mean. How spread out it is. What's that distribution look like? So we're going to do a test called standard deviation. So I'm going to type that down here. So you're going to go and find the standard deviation of each of your data sets. To do that, you're going to type equals. Again, we type equals when we want Google to do math for us. Then you're going to type STDEV, and you're going to open parentheses. Then you are going to highlight the data that you want to find the deviation of and hit enter. So there we go. We have a deviation of 16.67, blah, 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 blah. And I'm going to do the same thing over here. Equals STDEV, open parentheses, and I'm going to highlight the full data set here. I'm going to find the standard deviation of, okay? So kind of about the same. Just to make the numbers a little more digestible, one thing you could do in Google Sheets is you can set how many decimal places you would like it rounded to by using these controls. So I'm going to remove some decimal places. We'll bring it down to the nearest tenth. Okay? So period 1 had an average of 52 words per minute, and on average, everybody deviated 16.7 words per minute from the average. Okay? So that's kind of what deviation means. How much the normal person's data deviated from the mean. How far away from the mean was it? So we see we had a slightly higher standard deviation in period 2. So how are we going to use this in our chart? Well, first off, I'm going to come over here and go standard deviation, and I'm just going to bring these numbers over. I got 16.7 for period 1. And period 2, we had 18.4. So I'm just going to bring these numbers over, and I'm just making nice, neat little charts for myself that are going to help me when I'm analyzing data. Okay? So now let's bring up our chart, and let's go back into editing our graph. Uh-oh, it added stuff in? Nah, dude. What is this? What just happened? E3 to, why did it go to 5? Did I highlight that? I don't think I did. Well, maybe we could change that, E3 to E4. That didn't work. Well, let's start over. Delete our graph. I'm just going to highlight this portion. Insert our chart yet again. There we go. Now we're good to go. So there's Google trying to help us out, making things worse. So now I've got everything good. I'm going to come over here, and again, I'm just going to fix these axes. So my vertical axis, I'm going to label average words per minute. Okay. Oh, my face is in the way again. Sorry, guys. Let me move that over. Okay. All right, so I've labeled my y-axis here, and I want to get rid of, on my horizontal axis, I want to do period 1, period 2, space these guys out nicely, keep spacing them a little more, okay, great. So then I want to come to, on horizontal axis here, it said label font size. It was the text color that we used, and we set that to white. That got rid of it for us there. So there we go, awesome. So now we're good to go. I think one of the other things I did was the vertical axis. I set the minimums and maximums to something that made sense for us. So we did 0 to 80, which is kind of where everybody landed. Not many people were typing above 80, right? So here's our lovely graph. And does it show a difference between groups? I don't really know. Don't really know that it does. So what we can do is put in some error bars. You're going to click on series. You're going to click this pull down and select period 1. And then what you're going to do is come down, select error bars. Now notice it adds an error bar only to the period 1 bar. This is why we had to do this as 2 separate data series and why we had to make the charts we could. Or the way we did. So we made that little chart to make this graph in that format because it allows us to put separate error bars on each of our bars. So I'm going to do my error bar. I'm going to select, don't select standard deviation, select constant value, and you are going to set that to whatever the standard deviation was for that data. So in this case, we had a standard deviation of 16.7 for period 1. So I'm going to come over here and set this to 16.7. Now we notice that error bar got pretty big. Amazing, great, superb. You love to see it. So now we've got to go do this for period 2. So we go to period 2, we go to error bars, we set it to constant value, and then we set it to 18.4, which was the standard deviation of, oops, that class. Uh-oh, did I mess up period 1? I think I might have. Let's go back to period 1. Nope, constant of 16.7. So period 1 has a constant value of 16.7, and then period 2 has a, oh, that's percent, that's why, constant value of 18.4. So we can see that there's some pretty big spreads here. This does not look right for period 1. I don't know what's going on. Period 1, yeah, it's set to percent constant, please. There we go. Now everything's looking good. So now we have this error bars which are showing the distribution, and we can see how much these data sets overlap, which in this case is a lot. We can see that there's all of this space in here where they overlap, so maybe there isn't a significant difference between the two. Okay, now we still want to be able to quantify this. We want to give a number. Is there a difference between these two? We want a number for it. So for that, we're going to get a p-value. You might have seen p-values in some of the journal articles that you guys read. A p-value is basically a number that tells you, okay, what percentage chance is it that if I was to measure another person's typing speed, that I could figure out if they were in one class or the other. So like, there were some of you that were absent with this or just didn't answer the survey because you think I'm gone and you think it's a free-for-all, which, I mean, that's gonna hit you hard when I come back. I think here, like, if I was to measure your typing speed, would I be able to know what period you were in after I measured? What percentage chance would I have of getting it right or getting it wrong? And what a p-value does is we have a cutoff for it. And this is roughly 5%. We want to be 95% confident that if we measured another person, we would know what period they would belong to. That's our scientific standard. Just like 0.9, our squared value, is our scientific standard for having found a relationship, a p-value of 0.05 is our standard for finding a significant difference between groups, meaning there's only a 5% chance we would get it wrong if we measured a new person. Okay, and again, just the same disclaimer I had last time, this is an oversimplification of what a p-value is in an effort to, hopefully keep the focus here on science. So let's find out how to find this p-value. So in Google Sheets, we can find a p-value by doing a certain statistical test called a t-test. Okay. Now, a t-test has a couple different characteristics to it. So to get our Google Sheets to give us a p-value, we're going to write equals t-test, and we're going to open parentheses. Now, when we do that, let me move my face yet again. There we go. When we go to do this t-test, we need to highlight the data that gave us our averages. So I'm going to write equals t-test, as you guys can see. And make sure you're looking up here in the formula thing. It's going to make it a lot easier to read. And what I'm going to do is I'm going to highlight here. I'm going to highlight all of the boxes here, like this. So I'm going to highlight those boxes for period 1. So I'm going to highlight all of the words per minute values for period 1 that gave me that average of 52. Then I'm going to hit comma. Then I'm going to highlight all of the values from period 2 that gave me that average of 59. So as you can see up here, that's what I've done. Then I'm going to hit comma again, and there's some more stuff that we got to put in. And what I want to do is go to Google here, and I want to search t-test Google Sheets. And you'll notice there's a Google support thing. It's the first thing that comes up that tells us what we're doing. So when we do a t-test, right, in Google Sheets, it says, all right, we do t-test range 1. This is the first sample data to consider for the t-test. Range 2, this is the second sample of data to consider for the t-test. So we've done that, right? Then we need to specify how many tails these data sets have. Is it a one-tailed or two-tailed distribution? Okay, so guys, we talked about this. This is a two-tailed, two dinosaur tails going off in either direction. So this is two-tailed data. Okay, so we've got ourselves our two-tailed distribution. So we're going to put in a 2. So let's go back to our Google Sheet here. Okay, so we wrote t-test, highlight this section, highlight our next section, then we went comma, 2. So we're going to type a 2. Then we're going to hit comma again, and we've got to type in the next thing. So let's go back to our t-test document here, and you'll say this specifies the type of t-test. We have a paired test or a 2-sample test. This is kind of an important difference. We're going to use both of these. A paired test is when you have one. All right, here's an example of a paired test. I think this is an easier way to explain it. An example of a paired test would be a drug trial. Let's say 10 people come in, right? And we rate their severity of irritable bowel syndrome. How bad is your irritable bowel syndrome, right? And we have a control group and a testing group. We have 5 people in one, 5 people in the other group, right? Then what we do is we say, all right, I want you to take this drug. Now the control group is going to get a placebo. The experimental group is going to get the real medication. We're going to say, come back in a week, and then let's rate your symptoms, right? So when they come back again, we're going to rate them again. So what we're going to do is we're going to compare, right, a before and after. It's the same person. Kelly had a 5, and now she's down to a 3. Jim had a 5, now he's down to a 4. And what we're doing is we're comparing that same person before and after. This is a paired test, okay? What we're doing here in our data is not a paired test. Everyone took this, right? And we have our period 1 and period 2 people. There's not a before and after. So this is a 2-sample test. There's 2 different sample groups. There are different sizes. There's different people, right? So this is a 2-sample test. Then we have 2-sample equal variance or 2-sample unequal variance. this is definitely unequal variance. Most data is. So what we're going to do for ours is we're going to put in a 3. So if you have a paired test, you're going to put a 1. If you have a unpaired test or a 2-sample test, you're going to put a 3. So we'll come back to our data. Here we have equals t-test. Highlight our first variable, highlight our second, comma 2, comma 3, and close our parentheses, hit enter, and we get a p-value of 0.239. So what does this mean? This means to us that there is roughly a 23.9% chance that we get it wrong if we measure someone's typing speed. So there's not a significant difference between these groups, right? You know, pretty much a quarter of the time, we're going to get it wrong, right? So if we measure typing speed and go, okay, you had a typing speed of this, you're in this class, you're going to get it wrong. So we would say there is no significant difference between these two groups. All right. So after all of that, let us go through and let's quickly do this, following the steps for another sample set of data. All right, so let's go here. What I have is Google survey data. The people were polled. Do you eat cheese regularly? Yes or no? So that is the value that's going to give us our groups. And then we surveyed them on 3 things: their fart intensity, their bloating, and also their banana intake. All 3 of these variables were measured on a scale of 1 to 5. Okay, so here's my raw data. I'm going to show an example of how we're going to process these data based on a few hypotheses. So this is what you guys are going to be doing in your survey. Okay, so let's start here. Let's say hypothesis 1, I'm going to call it H1. Okay, hypothesis 1 is that there is a relationship between banana consumption and bloating. And then hypothesis 2 is going to be the different kind of hypothesis that we're talking about here. Hypothesis 2 for us is going to be there is a, well, let's be more specific. Let's say cheese eaters have a greater fart intensity than non-cheese eaters. So these are 2 fundamentally different hypotheses. One is a relationship between 2 variables, and the other is a difference between 2 groups. So let's do both of these analyses really quick from our sample data set. I'm going to do my best to remember to put the sample data set down in the description below. And if you like this and it was helpful, be sure to like, favorite, comment, and subscribe to the channel. Would really help me out, help the algorithm, all that stuff. But what we want to do is analyze both of these. So let's do the first one first, H1, a relationship between 2 variables. You guys know how to do this. So what I'm going to do is I'm going to make a new sheet here, and I'm going to call this one H1 because it's my first hypothesis. And I'm going to bring over only the data that matters to me, the bloating and banana intake data, right? Is there a relationship between these? So I'm going to copy that over to my H1 and I'm going to paste it in. So I've got banana intake and bloating here, and I've got all of these values. So what I'm going to do is I'm going to highlight these, right? And I am going to create a scatter plot. So I'm going to go insert a chart here. So let's insert my chart. There it is. There's my scatter plot. And man, oh man, it does not look like there's a relationship at all between these. So we have banana intake on the y-axis, bloating on the x-axis, right? First off, I would say that's kind of maybe not ideal, right? Maybe we would want to put banana intake on the x-axis as our dependent variable, or our independent variable, and then saying that bloating then depends, it's our dependent variable on that banana intake, and swap these two. But we don't really need to, because again, we're just looking to see if there's a relationship. So let me move my face back over here. Oh, I forgot to yell that time, sorry. And let's get series this, right? And do the things that we need to do. We add a trend line, make sure it's linear, we set the label to equation, and then we click show R squared value. And here we see we get an R squared value of 0.044, which means there is no relationship between these two. So we've answered that hypothesis here. Okay, awesome. So now let's go back to our raw data again, and this time we've got to find out if there is a difference between non-cheese eaters and cheese eaters and their fart intensity. So let's create a new sheet here at the bottom, right? So we come down here, say new, we're going to create a new sheet. We're going to rename this one. You can just double click on it to rename, or you can click right click on it and rename. So now we've got hypothesis 2, I'm going to put that after, right? And hypothesis 2 was cheese eating and fart intensity. So I'm going to highlight that data, and I'm going to bring that over to hypothesis 2. Oh, I did it wrong. Okay. Guess I didn't copy it. Well, that's okay, because we'll do another thing first. So if you recall, when we were setting this up last time, we had a setup like this. Fart intensity, right? So we had fart intensity, and then below that we had period 1, period 2. This time we're going to have cheese eaters and non-cheese eaters, right? So there we go, cheese eaters, non-cheese eaters. And what we've got to do is, I'm going to bring this down here to help break up the data set. There we go, love that. So there we go, I'm setting this up. So I've got to get all of the cheese eater fart intensity values in this column, and then all of the non-cheese eater fart intensity values in this column. That could be a lot of work when looking at our raw data, because nothing is necessarily in order. So here's what I'm going to do, guys. I'm going to highlight all of my data by clicking this box up here. So if you look at where the mouse is, if I click that, I'm going to highlight all of my data, and I'm going to sort it. So I'm going to go to Data, Sort Range, and I'm going to click on Advanced Range Sorting Options. You're going to check this box that says data has a header row, and now it becomes very easy. Sort by, what do we want to sort by? Well, let's sort by, do you eat cheese regularly, from A to Z. So I'm going to sort that, and I get all of my no's first, and then all of my yeses. And it keeps everything together as long as you highlight all of the data. It's very important to highlight all the data when you do that. If you just highlight the do you eat cheese regularly column, you're going to mess up your entire data set. So we have all of our no's. So let's take all of our no value fart intensities. So I'm going to highlight just the no's, and I'm going to copy that. I'm going to go back to hypothesis 2 and paste that under my non-cheese eaters. Then I'm going to go back to to raw data again, and I'm going to highlight all of my yeses, right? Here we go. And copy that data over into the cheese eaters. So now I have my cheese eater data and my non-cheese eater data. Now I'm going to start constructing my table to make my bar graph. So what I'm going to do is I'm going to have my two groups, cheese eaters and non-cheese eaters, and I'm going to have average fart intensity on the y-axis, and I'm going to have our standard deviation, and I'm going to have our p-value as well. So now I've got to get the values into my chart. So here, under cheese eaters, we're going to get the average fart intensity. To do that, we type equals average, open a parentheses, and this is the average for our cheese eaters. So I'm going to highlight all of those and hit enter. Then I'm going to do the same for my non-cheese eaters. Equals average of my non-cheese eater fart intensity. So I'm going to get that average fart intensity for my non-cheese eaters. Awesome. So I've got that, right? Then I'm going to need to get my standard deviation values. To do that, I type equals STDEV, and I'm going to do that for my cheese eaters. I'm going to highlight again all the cheese eater data, and I'm going to highlight equals STDEV for my standard deviation of my non-cheese eaters. It's going to highlight all of their data. Amazing. And then I'm going to do my t-test. So notice how I'm doing all this before we do the graph, right? Because I'm just testing to see whether or not we've got relationships here, guys. I'm just testing to see if we do. If we do, we'll make a graph, right? But first, let's get the numbers. Let's get that data. So now we've got to do our p-value. Before we do this, we should do a little test. Should do a little test. Is this a two-tailed or one-tailed distribution? This will be interesting. So what I'm going to do is I'm just going to highlight my cheese eaters for a second. So it's kind of an optional step, but kind of important. And I'm going to make a chart. And I'm going to select from my chart, just highlighting those numbers, a histogram. And do I have a two-tailed data set when I make a histogram? I do. We can see it's low here, we have an average in the middle, and then it tails off again here. So what we're looking at is looking to see that we have a well-designed setup. We do. We have a two-tailed distribution. So that's going to help us with our p-value. So we're going to come in and make our p-value. We say equals t-test. We open parentheses. We highlight all of our cheese eater data, comma, highlight all of our non-cheese eater data, comma, and then we say, all right, how many tails was this? Ooh, yeah, this is a two-tailed data set, so we put comma 2. And then, is this paired or unpaired? This is unpaired again, right? This is a two-sample test because obviously this is not a before and after. This is two different groups being tested simultaneously, so we put a 3. So we set that up, we hit enter, and boom, we have a p-value of 0.04. We found a significant difference between these groups. Awesome. So now let's make our graph. So I'll move my, let me move my head over here for the graph making process, so I'm nice and out of the way. Now, in order to make this graph, you'll remember we highlight just this part of our little chart right there. We go, we click insert chart. There it is. Now this gave us a scatter plot. What's going on? What are you doing? Make sure you select our lovely bar graph here. Let me move this over just so we can see it a little better. Okay, great. I'm actually going to move it down so I could see that standard deviation when we need it, because you guys know we're going to need that a little bit. All right, so now let's go and fix the things we need to fix. Our axes, very important to fix these. So I'm going to get my vertical axis, and I'm going to label this average fart intensity, right? So I'm going to label that average fart intensity on the y-axis on a scale of 0 to 4, which is a little bit weird. Why is it 0 to 4? This question was asked on a scale of 1 to 5, right? So we've got to fix that. So let's get out of our chart axis and titles, go to vertical axis, and set the minimums and maximums to values that make sense, which in this case is going to be 1 to 5. So we're going to make sure we scale it on 1 to 5 because that's how the question was asked. Okay, awesome. So now let's go back to our chart axis and titles here, and let's go get the horizontal axis, and we've got to label this cheese eaters, right? And then we're just going to space it out, non-cheese eater. So we're going to label it here on the bottom, and again, we're just going to manually kind of hit space until these are kind of separated enough that we know that they're showing each thing on the side. This is not ideal. We're going to talk about a slightly better way of showing this in a second. We have to get rid of that awkward average fart intensity on the bottom. So we'll go to horizontal axis here, and we'll set the text color to white so it's not there. Awesome. So we've gotten rid of that. And now we've got our graph set up. But guys, now it's time to get series. Okay, so you're going to click on series, and we're going to select one group at a time. So we're going to start with our cheese eater. We're going to add an error bar. We're going to set it to constant, and then we're going to put in the standard deviation here. So what was our standard deviation? 1.11. So we'll do that. So let's leave it at 1.11. There we go. So there's our standard deviation, a constant 1.11. Why does it keep doing that, dude? All right, constant 1.11. Awesome. Then let's go to our non-cheese eaters. And let's go put in our error bars. Let's take a look at what that standard deviation is. This is 1.00, so just 1. So I'm going to click error bars. I'm going to select constant, and I'm going to put in 1. All right, amazing. So now we've got these error bars. Everything is looking good. Amazing. So we've shown a significant difference between these two groups. However, one thing that I kind of want to point out to you guys is this isn't really a polished graph, right? The bottom here looks kind of gross. So here's what I'm going to do. I'm actually going to come down here. I'm going to get rid of that horizontal title that we kind of just like made a mess of over here. Just going to delete that real quick. Get rid of it. Now our graph is looking pretty clean. And what I'm going to do is I am going to copy this entire graph. And then I'm going to come over here, and we're just going to just make a new Google slide right now. So Google Slides is kind of just a great tool to use, or PowerPoint if you're more comfortable with that. I would say probably most of us are more comfortable with Google Slides at that point. And I'm going to paste an unlinked version of this graph, right? Oh gosh, why didn't it copy the graph? That's awkward. All right, so let's come back to the graph. Make sure we have the graph selected. Get rid of that. There we go, select the graph. Control C, back to my presentation, paste, or not. There we go. So now I've got my graph in here. I pasted as unlinked because I don't want it to change, and it kind of like limits what we can do. But one thing that we can do that's really nice is, say we don't want the key. I'm gonna take a shape, little box, and I'm just gonna go like this, right over top. And I'm just gonna set the box to be white and the border to be also white. And now we've just got rid of that. And now if I wanna label things, I could just add a nice clean text box in here, right? And make this text say cheese, and maybe stack it eaters, right? And I'm just gonna make our text box kind of like that, and then I'm gonna go over here. Maybe I wanna center the text a little bit, right? Let's center it so they're stacked up kind of like that. Ooh, nice, right? Love it, love that, right? Let's drag that up right under this box beautifully. Okay, so now what are we looking at? We've got cheese eaters, awesome. Let's copy that. Let's paste it again so we just get an identical version, and let's drag that right under the red box, just perfect. And we'll just set this to be non-cheese eaters. Let's make it a little wider. Kind of mess that up just a touch. There we go, non-cheese eaters. And now this looks a lot cleaner than our kind of just awkward version from before. This looks a lot cleaner. Now the next thing is, how do we show that there's a significant difference between these groups? You'll see this a lot on kind of some of the journal articles that you've read. I'm going to click the line tool. I'm going to draw a line here, if it lets me. So line, here we go. Now I'm drawn. I don't want it to snap to anything. Hopefully it doesn't. Okay, so I'm going to draw a line right above there. And I'm going to make sure, I'm going to make it a little like heavier, maybe like a 4-point line. Yeah, that's nice. Right, so I'm going to draw a line like that. And I'm going to draw a new line. I'm going to snap it right to the top of this one. What I'm doing is making a little bracket here. It's going to look like this. And let's draw one more line from the top there. Oh, I forgot to increase the thickness of that one. That's okay, right? Set this one to 4, just like the other one, and this one also to 4. So now what we did is we made like a little bracket showing a comparison between these. And then a lot of times what you'll see is journal articles that put an asterisk. Now I'm going to highlight this asterisk because I want it to be a lot larger. So let's just make it a really big asterisk. Oh yeah, just like that. That's beautiful. Beautiful asterisk right there. So I'm going to take this and I'm just going to kind of drag it like right on top. I want to get it centered ideally on our little thing. So now we have this beautiful graph, and that asterisk indicates that we have found a significant difference. In the note section of your graph, you're going to write asterisk signifies p less than 0.05. So this is a great way of putting together a graph. And again, one of the things I want to emphasize, hopefully you guys got all the steps down, making a bar graph is more artistic than it is an analysis. Our analysis here, guys, was this, right? Our analysis was this chart right here. This chart here with the t-test and the p-value, that's our analysis. That's us doing the science, right? This graph that we made is basically an artistic representation of that. So it's a little bit different than using a scatter plot like we did. So hopefully you guys have all the steps of finding a difference between two groups together. I've been talking for way too long right now, and my voice is kind of shot. I'm gonna go drink a glass of water. And on that note, you guys need to now do the following. Where's the mouse? I don't know. Oh, there it is. Okay. All right, back in the classroom. You're going to come up with 2 hypotheses to ask the freshman to find a relationship between 2 variables, like we did between bananas and bloating, right? Then I want you to come up with 2 hypotheses to find a difference between groups, okay? So where you ask survey questions, put people into 2 or more groups, and find a difference between those 2 groups. You're going to come up with that hypothesis and then come up with the questions you would need to ask in a survey to do that. You guys are going to be submitting your questions as a group to me by the end of the week, and we'll be putting together a master survey that we are going to send out to the freshmen. So what you need to do is get that all set up. Actually, by the end of the week sounds really long for that. So what we're going to do is we'll do this by Wednesday. You guys will have this due on Wednesday. Nah, you know what? Forget it. Just have it due by Thursday. Have it due by Thursday. You guys will have all of your questions made. Remember, if it's a variable, it has to be quantifiable. And if it is a group, you need to make sure it has grouping. And you guys are going to be writing these questions in a Google Doc and submitting it to Classroom to put together so we can survey the freshmen. All right, hope you guys have a great rest of your week, and I'll see you guys all later. Bye.